Hello everyone. On April 13th, 2023, I gave a talk at the NISTM National Institute of Storage Tank Management, which is probably one of the best annual storage tank conferences there is. I had a solemn topic about the evolving and looming environmental disaster called forever chemicals and the planning and progress to recover from it from EPA and society. I'm going to talk about what the problem is, how it evolved, the chemistry and its health effects, what EPA is doing about it, and how you can protect yourself. Enjoy. Take a good look at this list. Pause the video and take a stroll down environmental memory lane. Every one of you has lived through some of this. Do you remember the ones that you should? These are incredibly significant events. And the last one on the list is perhaps the most challenging and difficult societal problem that EPA and society has ever faced. Notice that I pronounced the word PFAS instead of PFAS. PFAS is a class of chemicals including over 5,000 compounds. It stands for per and polyfluorinated alkyl substances. PFAS, on the other hand, is just one of the PFASs. Let's suppose that I'm a chemist in the 1940s and can bring to the public chemicals that have wonderful properties like permanence, ability to prevent stains, protect carpets, make frying pans non-stick, fast food packaging and wrapping that does not let grease seep through it, and so on. One of the PFASs was superb for firefighting foams. It saved many lives by being able to quickly and efficiently knock down fire and smother it with the unique properties of the fluorinated hydrocarbons. This foam is, of course, AFFF, or aqueous film forming foam, used at airports, military installations, at fuel terminals, refineries, and so on. Unfortunately, these products are no longer considered wonder chemicals because they have side effects. The word anthropogenic means that these chemicals did not exist in our world prior to the 1940s, when they were invented by DuPont. Today, these chemicals are no longer wonders that they once were, as they are now known to be toxic at very low concentrations and are polluting the earth. Firefighting practices and drills using AFFF is a significant contributor to this pollution. The foam was once thought to be benign, and after extinguishing fires it was washed into the ground and surface waters on a daily basis. The term forever chemicals is a play on words. The F in forever and the C in chemicals refers to the fluorine-carbon bond, which is super strong and accounts for the persistence of the chemical and its ability to avoid breaking down chemically over time. Professor Joe Allen of Harvard first used the term in a 2018 op-ed, and it stuck. Look at this beautiful natural sight. Water is ubiquitous, but observe the molecules of PFAS that contaminate the water and air. They are now ubiquitous. So what are the side effects of PFASs? First, they bioaccumulate in living systems. In effect, you become a human filter for whatever you drink or ingest. Second, they biomultiply in the food chain. That is, if a fish has some level of PFAS in its body, a predator will concentrate the PFAS by a factor of 5 to 50 in their bodies, and so on. These chemicals are pervasive and persistent chemicals, so that Professor Allen's nickname, Forever Chemicals, is apt. In 2022, measurements showed that 4 PFASs were found in rainwater all over the world, even on continents where it was never manufactured. The biggest users of AFFF were the U.S. military, petrochemical, and aviation industries. In the early 2000s, U.S. manufacturers agreed to stop producing the two most common PFASs, perfluorooctane sulfonic acid, or PFOS, and perfluorooctanoic acid, or PFOA, also known as C8 for their 8-carbon backbone. However, they were replaced with other chemicals such as Gen X or others about which we know very little relevant to the toxic effects both long and short term. The EPA health advisories of 2017 showed a limit of 70 parts per trillion, which has been revised down to 4 parts per trillion. To understand this, we must have some comparison for understanding. An Olympic swimming pool is 2,500 cubic meters. Most of you know what size a milliliter is. I have a normal 5 milliliter eyedropper and a really skinny one for cat meds that is 1 milliliter. 1 milliliter in 500 Olympic-sized swimming pools represents 1 part per trillion. I believe the Seawise Giant was the largest ultra-large crude oil ship ever made. It would hold 160 of the largest U.S. crude oil tanks, or 10,000 Olympic swimming pools. To reach a limit of 4 parts per trillion contamination would only require a small medicine cup of 62 milliliters of PFAS. That is the scale we are talking about. We have to talk briefly about the chemistry so that you will understand why there are thousands of PFASs. As I said before, the term PFAS stands for per and polyfluoroalkyl substances. Per means that the carbon branches are saturated with fluorine, whereas poly means that not all of them are saturated, but can have some other element such as hydrogen. These compounds were invented in the 1940s. But concern over perfluorooctanoic acid arose when it was detected in human blood near chemical manufacturing sites. Today there are hundreds of different PFASs in the water, soil, and air. Here are a few graphics of the carbon atom which makes life, and thus toxins, possible. Carbon has an atomic number of 6, meaning that there are 6 protons in the nucleus. These schematics show that carbon has 4 bonds, but what I want to point out to you is the tetrahedral shape shown in the lower right. Wherever there is a hydrogen shown, a carbon branch or other atom such as fluorine can attach. In the top left, the kinky line represents the 8 carbons, and the wiggle is intended to show the tetrahedral connections between carbon atoms. Each node and the endpoint are carbon, so that you can count 8 such nodes. The hydrogen is not shown to reduce clutter. There is a stick representation of the molecule octane. Below are different representations such as the ball and stick model, and at the bottom is a space-filling model. On the right, we can substitute each hydrogen of the octane backbone with fluorine atoms. This would make perfluorooctane. One of the common PFASs, and one which will soon be regulated by EPA, is PFOA, for perfluorooctane sulfonic acid. There is a sulfonic acid group attached to a carbon bonding site at the end of the perfluorinated carbon backbone, and it is filled with fluorine atoms. I can switch out the sulfonic acid group with a carboxylic acid group and get PFOA. You can see that there can be, and actually is, a combinatorial explosion of these fluorinated organic compounds, resulting in over 5,000 PFASs. This diagram shows a family tree of just a few of these compounds. Consider increasing the carbon backbone by 1 atom from 8 to 9. Then PFOS becomes PFNA for perfluorononanoic acid. Again, this illustrates the diversity and large numbers of these types of compounds. Consider the 2 water bottles. One has BPA, or bisphenol A, in the plastic, which has been in the news for years now, and which has negative health effects. One of the 2 bottles is labeled BPA-free. Which one would you buy? Obviously, you would buy the BPA-free bottle. However, what you would not know is that the BPA-free bottle has been manufactured with a chemical substitute, BPB. It turns out that this is just as toxic and dangerous as BPA. If that doesn't work, then BPS can be substituted. This is not theoretical. This is what has actually occurred in our open markets with respect to chemical substitution. Professor Allen calls this chemical whack-a-mole. This is exactly the problem with PFASs. Many of the PFASs break down into other PFASs, which may be as bad or worse than the original compound. You can see that it could be nearly difficult to impossible to achieve a regulatory goal of attempting to keep these anthropogenic chemicals out of the water and atmosphere on our planet. The investment of time, money, testing, and experimental work to determine the short and long-term toxicological effects of just one compound is huge. It's a Herculean effort to understand a few dozen, let alone thousands. This is the process attempting to be managed now by EPA. Luckily, $10 billion to study this infrastructure water supply problem has been allocated by the Bipartisan Infrastructure Bill, or BIL, that passed Congress recently. This diagram shows the transport of PFASs through the various media and systems. As stated earlier, the PFASs are finding their way to all locations all over the earth, even where there is no manufacturing of these compounds. Here is a U.S. map showing where PFAS levels are above the proposed drinking water limits. Maps of Europe look the same. In fact, the whole Earth looks as though it has a case of the measles. Here is a plot of various cities in the U.S. and the PFAS levels in tap water. Here is the 70 ppt limit, which has been reduced to 4 ppt, shown by the red line. Note that most locations are not contaminated, but locations near airports and military bases where AFFF has been used for decades are likely highly contaminated. Let's talk about health effects now. The Patel study indicates human blood levels of PFAS in most U.S. citizens is at 1.56 ppb, which is 1,560 parts per trillion, way above the EPA health advisory limits. The good news is that these chemicals are not really forever. See the half-life periods. But at a half-life of 15 years, you are always going to be loaded with PFAS. Pause the video and review the other health effects. As a simple arithmetic exercise on half-life, assume that you have a PFAS level of 200 parts per trillion today. If you live another 60 years, how much PFAS will be in your system at the end of your life if you ingest no more PFAS starting today? I will give you the answer at the end. The y-axis is in micrograms per liter, which is the same as parts per billion. The PFAS line comes from data where the chemicals were dumped into the rivers but were terminated in 2000. Note the effect of half-life in the population. But 5 ppb, or 5,000 parts per trillion, is still over 1,000 times higher than the soon-to-be regulated limit of 4 ppt. Now we will talk briefly about the regulatory scene on PFASs. There is some terminology that is important to understand regarding future regulations that will affect the potable water supplies throughout the country. The Safe Drinking Water Act authorizes EPA to issue hazardous advisories on contaminants. PFAS will be added to CERCLA, or Superfund. The lifetime health advisories identify levels to protect all people. In 2016, EPA published lifetime health advisories for PFOA and PFOS for drinking water at 70 parts per trillion. And MCLG is a maximum contaminant level goal, which is not regulated. The MCL is a maximum contaminant level that can be regulated. For PFOA and PFAS, the health advisories were reduced to 4 ppt. This slide shows the health advisories for 4 of the PFAS chemicals. On March 14th, EPA published in the Federal Register a new rule that affects the National Primary Drinking Water Standard, or NPDWS. This affects public potable water suppliers, and as you can see, there's a hazard index. This is a way to aggregate the various PFASs so that if there is more than one in the water supply, they can be regulated as a group, not to exceed the hazard index level. Here is a diagram showing the EPA rulemaking process. As of April 2023, we are in the rulemaking process. We are in a comment period that ends on May 30, which will be due from the public. This slide is from EPA's website on PFAS. Pause the video to understand the next steps in more detail. This slide shows where we are in terms of milestones for creating a revised NPDWR standard, which is anticipated to take effect in 2026. Fortunately, there are treatment options that work to a level of parts per trillion. GAC and ion exchange, as well as reverse osmosis work. Each has advantages and disadvantages that we can't go into now. To me, it is super annoying that society and its regulators play the same playbook over and over again each time a huge environmental problem arises. We do not anticipate these consequences or do a societal management of change on the introduction of new chemicals. Why is it that the industry must use management systems such as MOC, but society's representatives, the regulators, are not bound by these good rules? Instead, we play the whack-a-mole game hoping things will work out. In my view, the PFAS problem make DDT, lead, mercury, and PCBs look like child's play because of the low concentrations of concern and the thousands of pollutants we are talking about. Lawsuits are being filed every day, and there is a massive set of cases working their way through every segment of commerce where PFAS was manufactured, handled, or delivered to the end user. But how can you protect your family right now? The first thing to do is be concerned if you are in a hot spot, and if you are, the chances are that you already know quite a bit about PFAS. However, you can always search your potable water supplier for more information and check if they publish PFAS levels in the water. Be aware that they may not report this information or simply do not know. The new EPA rule will require all potable water suppliers to test and monitor for 6 of the PFASs. You can go to a home repair center or order activated carbon units or reverse osmosis cartridges for drinking water. Fortunately, human skin is superb at keeping PFASs out of the body, so all you need to treat is the drinking water. But this is something you should research for yourself. I will keep you updated on the new NPDWS standard as it progresses. Also, I would like to point out that my belief about why the PFASs do not break down as most other toxins do in various life forms. From an evolutionary biological perspective, PFAS has only existed on planet Earth for less than 100 years, but it takes millennia for life to evolve the enzymes that do the work of breaking down toxic chemicals. Thank you.